Good morning, teachers, and one and all present here. Today, the topic on which we are giving the presentation is radio interference measurement. So, radio interference, which is also called as frequency interference, when in the radio frequency spectrum, is a disturbance generated by an external source that affects an electrical circuit by electromagnetic induction, electrostatic coupling, or conduction. So the reason why the radio interference takes place or the causes of radio interference is radio interference may prevent reception altogether, may cause only a temporary loss of signal, or may affect the quality of the sound or picture produced by your equipment. The most two common causes of interference are transmitters and electrical equipments. So the topics which we going to cover in this seminar is first is what is interference, second importance of radio interference measurement, third reason for noise voltage production, fourth measurements of radio interference voltage, fifth important parts of circuit diagrams, sixth circuit diagrams for measurement of RIV, seventh remedies to prevent radio interference. So, first topic is what is interference? The combination of two or more electromagnetic waves to form a resultant wave in which the displacement is either reinforced or cancelled is called as radio interference. Is called as interference. When you have unwanted signals combining with your intelligent signal, you have interference. Usually, the result signals plus interference signals is stronger. So, from this next slide, Girish will explain you.
As Jayesh has explained the importance of radio interference measurement, the main cause of radio interference is electric noise. So, the electric noise may be defined as the result of more or less random electric signals getting coupled into circuits where they are unwanted. In this slide, we are going to see the various reasons which are responsible for the production of this noise voltage. As we know, in case of AHV transmission lines, the voltage between two transmission lines is very high, and we are using air as the insulating medium between these two conductors. If the voltage between the conductor is of alternating nature, then the charging current may flow between these conductors, and the as the this charging current increases, the electric field intensity also increases, which may cause ionization of the air, and the air may get breakdown, and we may hear the hissing noise from that area and produce the noise voltage. So the another reason for noise voltage production is the partial discharge in case of overhead insulators, which are mainly caused due to aging of the insulator, and sometimes there may be dust present on the insulator dust due to atmospheric conditions. The third reason for noise voltage production may be the sparking at the commutators and brush gears in case of electric motors or alternators when they are rotating at a very high speed. Then the another reason for noise voltage production may be the bonding between the porcelain body of the solid insulator fitted on the metallic pin. It may also cause the noise voltage. The main reason responsible for production of noise voltage may be the overhead conductors, which are subjected due to very high voltage stresses in case of abnormal conditions or faulty conditions such as electric lighting or some uh, short circuit conditions. We can hear noise voltage. Also, the noise voltage can be occurred due to abrupt changes in the climate conditions. So that's all. We are going in the next slide. We are going to see the measurement or testing of radio interference voltage. So what is radio interference voltage? The radio interference voltage is the term that we have created to measure the electric noise voltage in terms of the line to ground voltage. The noise generated in the radio frequency band as a result of corona or partial discharge in high voltage power apparatus can be measured by the term of radio interference voltage. So we are going to measure this radio interference voltage in order to minimize the radio interference. We are going to use the device as such as the radiated radio interference. The circuit diagram that we are going to use to develop the device that will measure the radio interference consists of following parts such as radio noise meter, local oscillator, radio frequency amplifier, detector, mixer, multi-input circuit, intermediate frequency amplifier, and output circuit having detectors and meters. So the next part will be explained by Abhirup.
So, as Jayesh and Girish have already explained you the importance of radio interference measurement and reasons for noise voltage production, such as corona or partial discharge, or basically through insulation, that is pollution among on the insulation surface, and all such reasons. I will tell you about how can we measure this radio interference voltage. So as you can see on the screen, there is a circuit diagram for measurement of RIV, that is radio interference voltage. So see, this the first stage is basically the HV transformer, that is it will act as a source side. Then we can see there is a LC circuit, it will act as a filter. Then this is the apparatus being measured. Suppose if a transformer there are bushings which may produce high frequency signals. Now see what happens is, as the high frequency signals are produced here, they will be directly reflected towards the inductor. So this L2, so the high frequency signal which may be produced by the transformer bushings will be reflected towards the inductor side. Now this C2 will basically act as a coupling capacitor, that is it will couple. Suppose this is the whole input side and this is the load side, that is the apparatus being measured. So this C2 will act as a coupling capacitor, that it is will basically couple the two stages. Now see what happens. Suppose the transformer bushings are producing very high frequency signal, then they will be reflected towards L2. Now through L2, this R1 and R2 will act as basically a potential divider. So basically, as R1 and R2 will act as a potential divider, so this R1 arm belongs to low voltage arm and R2 arm belongs to high voltage arm. So basically the output of LV arm, that is the R1 arm, will directly be connected to the measuring set. So now suppose the signal which has arrived, the voltage which has arrived across L2 will be reflected through the R1 arm to the measuring set, and there in the measuring set we can see that whether the frequency, by generally checking the waveform, we can see that whether high frequency or level is produced or low frequency level is produced. This is basically the standard. This circuit is basically according to the British standard. Now coming to the next circuit which can be used for measurement of radio interference voltage. So this is one of the next circuit which can be used for measurement of radio interference voltage. So we can see here that this is the radio interference meter, that is MR1, that is measuring. M will act as a radio interference meter and R1 will act, R1 represents the R1 represents the meter impedance, that is meter impedance. Now suppose this is PC. PC, that is, this is a power system conductor. Suppose this is a power system conductor, and now what happens is, we can see that due to corona discharge or any type of discharge, we can see that there is a high frequency signal which will be produced. There is a high frequency signal which will be produced. Now to measure this signal, that it is whether it is within the limits or not, we can measure it by using this circuit also. This circuit is basically implemented for power system high frequency signal measurement. So basically the first circuit, that is the circuit which I have mentioned already, that is the British, according to the British standard, and this circuit is approximately same. See, this C will now also act as a coupling capacitor. This CA is a coaxial cable. This R will basically collect the will act as a collector, that is, it is a measuring impedance that it will sense or collect the radio frequency signal. This G is for safety purposes, that is, it is left open for safety purposes. This C1 and C2 will be acting as stray capacitance. These S1 and S2 switches are for basically short circuit switches, and this L1 is basically acting as a choke which is used for tuning. Now see what happens is, as the power system conductor may experience corona, and due to result of which high frequency signals which will be produced. So now these high frequency signals will be collected through the resistor. Now this through the now as the resistor will collect the high frequency signal, basically it will sense. Now this high frequency signal will be passed through the coaxial cable, and through the coaxial cable it will be passed through the radio interference meter, where there is also one R1 which will be measuring meter in impedance. Now see, now this meter impedance will basically sense, or this radio interference meter will basically sense, or by check the waveforms or patterns, we can see that whether the high frequency signal produced here is within the limits or not. So basically these are the two circuits which can be used for measurement of radio interference voltage. Now the next section will be explained by Vijaya.
Now we are going to see how to prevent radio interference. It is always better to prevent than to try to solve problems, isn't it? In this section, we will give you some tips to prevent and eliminate radio interference. In case one here don't work, we recommended you to check out the next section, in which we address other problems that only sound like radio interference but are actually caused by other things. Filters usually starts with an AC line filter that prevents bad signal from entering the power supply or powered circuit. Filtering is commonly used to reject noise outside of a predefined frequency range. Second one, don't overdrive the system. Third one, use balloon. Fourth one, RF choke. In RF choke, mainly used to block RF from power supply line to high frequency RF circuit. Fifth one, Faraday cage. The metal layers are grounded to dissipate any electric current generated from external or internal electromagnetic field, and thus they block large amount of the electromagnetic interference. Sixth one, cable, and there are many more like moving the wires, and this is the easiest thing. Next one, putting on some ferrite cores. Ferrite cores can be great help. All you have to do is attach one or two ferrite core to your speaker's wire. Ferrite core are also called ferrite braids or choke. 9. Checking for viruses. And next, using shorter wires. Unshielded wires can act as an antenna. Longer wires catch radio signals to a greater extent than shorter ones. By using shorter wire, you can at least reduce the radio interference that is bothering you. Next one, buying shielded wires. If nothing works, shielded wires will almost certainly stop all radio interference from going into your speakers. Thank you. Please subscribe, like and share.